Don't you think we're done? Don't you think we're done?
In this lecture, we're going to talk about constructors. Constructors are a special method which is run every time you create an instance of the class. To keep things simple, I'm going to add another class in this file, and I'm going to call it program. And down here, I'm going to create an instance of the class. I'm going to choose a name to refer to it. I'm going to say my program equals to new program. So right here we have created an instance of this class. So we created a new object of this class. So now in our program class, I'm going to create a new constructor. I'm going to set it public. We're going to talk about access modifiers in the upcoming lectures. Public is one of them. And now let's get back to our constructor. The difference between the constructor and the method is that the constructor doesn't have a return type, not even void. So a method must have a return type, whilst the constructor cannot have a return type. The name of a constructor must always be the same of the class. So in this case, it's program. It has the parentheses same as the method, and the curly braces as well. Constructor must match the name of the class, so the first letter should be uppercase. So I'm going to create here a sysout just to see when this constructor is running, and I'm going to call it first constructor. So if I run this class, we're going to see the first constructor on the console. The constructor would run even if you would just type new program, parenthesis, and semicolon. So if we run this, the constructor will run again. So it's this part of this statement that makes the constructor run. So this is the important bit. So another thing that you use constructors for is initialization of instance variables. For example, I will say here int value, and within the constructor I'm gonna give this variable a value. Let's say value equals to 12. Now I know that every time this constructor runs, this variable called value will have the value 12. Now, just like methods, constructors can also have parameters. However, the name of the constructor will always remain the same, as we already said, because it has to match the exact name of the class. So I'm gonna give here a parameter called value. Here you can see that we have declared a local variable called value, so we've given it the same name as the instance variable, which is called value as well. if we say value equals right here, this variable right here will be used. So as you can see, local variables mask the instance variables. So in the scope of this constructor, if we say only value, this parameter right here will be used. And you may be tempted to say value equals value, and you might mean that you want this instance variable equal to this local variable, but that is not how you do it. That is what we use this keyword for. So we should say this dot value. This dot value refers to the instance variable, and it sets it equal to this parameter right here. So now the value of this parameter equals to 12. So that is what we use this keyword for. Then I'm gonna add the sysout statement, and I'm gonna say second constructor. And now you can think of this part here as a call to the constructor. So if we want to call the second constructor, which takes one parameter, an int variable, we should say program, my program 1, for example, new program, and we should give it an int value, and then the semicolon. First, we should add a semicolon right here, and if we run this program, both of the constructors will be run. So here is the first and the second constructor. So Java will be looking at the parameters and then will mesh the constructors. So if we add an int value into the parentheses, Java will be looking for a constructor that has an int variable as a parameter, which is this one right here. And if we give in empty parentheses, it will output the constructor with no parameters. We can also have a constructor that accepts multiple parameters. For example, public program int value. I'm gonna add here another instance variable, string text for example, and I'm gonna say here string text. Then I'm gonna set these local variables equals to our instance variables. This dot value equals to value in this dot text equals to text. I'm gonna say here sysout third constructor. Now to invoke this constructor in our main method, we should give the constructor two parameters, one int variable and a string variable. So I will say here program2 equals to new program. I'm gonna give it an int value and the string value. I'm gonna put here a semicolon. So now if I run this, all of the constructors will be called. So here we added the third constructor. You can see the Java is selecting the right constructor depending on the parameter list. So another thing that we're gonna mention in this lecture is that sometimes we wanna call a constructor within another constructor. So if we would like the second constructor to be called whenever we call the first constructor, we should say something like this. So we're gonna use the this keyword once again, but here it's not the same as we used it right here. This one is followed by the parenthesis, and to call the second constructor you should give the proper parameter list. So for example we should say here 5. So now every time this constructor is called, it will call the second constructor as well. This followed by parentheses and an int value will make this possible. So this is what we call the call to the constructor. So you cannot call constructors, for example, program 5. This will give you an error. This will not call this constructor. The only way to call constructors is by using this keyword or the super keyword followed by parentheses, which we will talk about later on when we will learn inheritance. But for now, this is the right way to call the constructor. And don't forget, this must be the first line within the constructor. So once again, this followed by parentheses is a call to the constructor, whilst this dot variable is used to set local variables equals to instance variables. So even though they might sound the same, they are totally different. So now if we run this, you can see that when we call the first constructor, it will first call the second constructor and then run the first constructor. You could call the constructor with no parameters as well. you will just leave the parentheses empty. So as you can see right here, the first constructor is called from the third constructor. As we said, this followed by parentheses, the call to the constructor must be the first statement. So you cannot call two constructors within a constructor. So this is not valid because this must be the first line within the constructor. So you cannot call two constructors within one constructor. So that's it for the constructors. I'm gonna see you in the next lecture with more interesting stuff. So see Hello and welcome back. In this lecture we're going to talk about static and final keywords. Here I am in Eclipse and I have my main program right here. I'm going to start by creating another class and I'll name it student. I'm going to give this class two variables of type string, and I'm going to give it another variable again of type string, and I'm going to call it student class. In fact, I'm going to make this variable static, and we're going to take a look of the differences of this variable and this variable. And in my main program I'm going to declare two objects. I'm going to say student1 equals to new student, and student2 equals to new student. Now each of our objects has a copy of our string variable name. So if I say student1 dot name equals to Stephen, and student2 dot name equals to Daniel, and of course I can display them with a sysout statement. Sysout, control space, student1 dot name, and sysout, control space, student2 dot name. And of course if I run this, it's gonna say Stephen and Daniel. And the difference from our static variable right here is that each object does not get its own copy. Static member variables, also known as class variables, belong to a class, and exists only one copy of this variable, because there is only one class. And to access this variable, I should type the name of the class, dot, and then the name of the static variable, that is student class. And I'm gonna give it a value. Let's say that the student class is Web Development Fundamentals, and I can display this one the same way as the non-static variables. Sysout, control space, student class. So non-static variables are also known as instance variables because each object gets its own copy, and static variables are also known as class variables. So if I run this, I have my Web Development Fundamentals class right here, and of course the student names below. And let's see a difference between static and non-static methods as well. So if I say here public, I'm gonna say student name, and right here I'm just gonna print the student name. I'm gonna say here name, and I'm gonna replace my sysout statement with a call to this method. I'm gonna say student1 dot student name, and student2 dot student name. I'm gonna add the return type of this method, which will be void. So if I run this, the results are gonna be the same as before. So we have the name of the class and then the student names. So I'm just calling this method to output the name of the students. So if I add the static method right here, I can access it via class. So let's say public static class info. I'm gonna add the return type as well. I'm just gonna put a sysout statement right here. So to access this method, I have to use the name of the class, in this case student, dot, and then I'm gonna add the name of the static method. class info. So if I run the program now, it displays Java right here. So I'm accessing the data of class info by calling first the name of the class, then the name of the static method. Well, there is something to keep in mind when we're talking about static variables and static methods. One thing you should remember is that static methods can access static variables because they both belong to class. So if I say here student class, it's going to show the value of our static variable right here, which is web development fundamentals. However, a static method cannot access instance variables. So for example, if we say sysout, control space, and we say here name, it's going to give us an error that says cannot make a static reference to the non-static field name. Which makes sense because the static data exists before making any object of the class. So it doesn't know about the value that we've given to the instance variables through objects. So I'm going to comment this out and I'm going to say this gives you an error. And on the other hand, non-static methods can access static data. So if I say here sysout, this as well makes sense because by the time that we've got the objects, of course, we've already got the class. And the methods that are linked to objects, of course, can access the class data. And I'm going to add here the non-static variable as well. I'm going to say name plus is enrolled in plus student class. And I'm going to add some space in here. And to make it less confusing, I should delete this system out println statement right here. So if I run this, it's going to say Steven is enrolled in Web Development Fundamentals and Daniel as well is enrolled in Web Development Fundamentals. So don't forget that non-static methods can access static data. So you might be wondering when you would use the static data. And the typical example of static data is, for example, if we print out a value from a math class. For example, if we print out the value e and run this. So math is a class created by Java. And this class contains, for example, this e constant or the p constant, which we can use for our math equations. And let's see what we mean by a constant. So by constant, we mean that we cannot change the value of that particular variable. So if I say here math.e equals to 4, it will give us an error saying that the final field math.e cannot be assigned. So this means that this is unchangeable. Once it's created, you will not be able to change it. If we want to create our own constant, we can do something like this. So a convention in Java is that the constant variables are represented by uppercase letters. I'll create one right here. I'll say public static final. I'm gonna make it of type int, and right here I'm gonna say my, just to make it more readable, I'm gonna add an underscore right here, constant. And the keyword final right here makes this variable unchangeable. So once we've given this variable a value, we cannot change it. So when you have a final field, you have to assign it a value in the same line that you've created it. So I'm gonna say here 8. If we want to display our constant, our field is static, so it belongs to class. So first we should mention the class student.myConstant and then the name of the field. And now if we run this, it's gonna display our constant, which has the value 8. And this constant can be int, string, double, or any Java type. It doesn't have to be int. Now another use of static fields is counting the objects that you create. So for example, if we add here public static int count and we give it a 0 value, and here we will also add the constructor, and remember that there is no return type for the constructor. So this constructor is run every time we create an object. And here I'm gonna increment count. So count is a static field, which means it belongs to the class. We said that there is only one copy of the static variable, so that copy will be shared through all the objects. And if I want to display the count, I'll say right here sysout control space. I'll say before creating objects plus, and I'm gonna add our count variable, and I'm gonna copy the statement and I'm gonna paste it after creating the objects. So if I run this, it's gonna say before creating objects the count is 0, and after creating the objects the count is 2, because there are 2 objects. So counting is a very common use of static variables. So these are static and final data. If you've never seen them before, I know there's a lot of information at once, but of course you should practice them, and once you've practiced them, it's all gonna make sense. So I'm gonna leave this code in the resources section in case you want to play around with it and change the data, change the names of the methods and the variables, and try them yourself. It's a good way to understand them. So I'm gonna leave this lecture right here and follow me through following lectures to continue learning some other interesting Java stuff. See you there. gonna leave this code in the resources section. There's a lot of information on use of sound variable, static field, which means it belongs and value 8.
lost track of time, don't know how to feel, but I'm not sorry. I'm lost in your eyes, are you even real? But don't you worry, I'm not looking for the one, no, I just wanna have some fun. So let's get drunk tonight, 'cause fuck how we feel. But for now, I won't give it all away, 'cause I don't think I'll stay. enjoy it. I'm not thinking about forever. I won't care if we don't end up together. Let's get high tonight, 'cause fuck how we feel, yeah. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Oh, yeah. Doesn't wanna fall in love. Yeah. Doesn't wanna fall in love. We've lost track of time, don't know how to feel, but I'm not sorry. I'm lost in your eyes, are you even real? But don't you worry, I'm not looking for the one. No, I just wanna have some fun. So let's get drunk tonight, 'cause fuck how we feel. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. 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 May not see eye to eye, but we can be chill for just this moment. So turn out the lights and let's make a deal to just enjoy it. I'm not thinking about forever. I won't care if we don't end up together. Let's get high tonight, 'cause fuck how we feel, yeah. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Oh, yeah. Doesn't wanna fall in love. Yeah. Doesn't wanna fall in love. We've lost track of time, don't know how to feel, but I'm not sorry. I'm lost in your eyes, are you even real? But don't you worry, I'm not looking for the one. No, I just wanna have some fun. So let's get drunk tonight, 'cause fuck how we feel. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. 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 May not see eye to eye, but we can be chill for just this moment. So turn out the lights and let's make a deal to just enjoy it. I'm not thinking about forever. I won't care if we don't end up together. Let's get high tonight, 'cause fuck how we feel, yeah. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't We've lost track of time, don't know how to feel, but I'm not sorry. I'm lost in your eyes, are you even real? But don't you worry, I'm not looking for the one, no, I just wanna have some fun. So let's get drunk tonight, 'cause fuck how we feel. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna feel. Doesn't wanna fall in love. May not see eye to eye, but we can be chill for just this moment. So turn out the lights and let's make a deal to just enjoy it. I'm not thinking about forever. I won't care if we don't end up together. Let's get high tonight, 'cause fuck how we feel, yeah. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Oh, yeah. Doesn't wanna fall in love. Yeah. Doesn't wanna fall in love. We've lost track of time, don't know how to feel, but I'm not sorry. I'm lost in your eyes, are you even real? But don't you worry, I'm not looking for the one, no, I just wanna have some fun. So let's get drunk tonight, 'cause fuck how we feel. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna feel.
I'll be your anything if you be the one to take me home. 'Cause right now everything makes me wanna leave this place and roam. Make me feel alive. Take my hand and run, let me be the one. Let's just take a dive. Nights only begun, don't you think we're done? Don't you think we're done?
Need a while.
Hello everyone and welcome back. In this lecture we're going to talk about a very important Java topic, which is inheritance. So I'm going to start by creating a new class. Until now we've created classes in the same file. Now we're going to create classes in separate files, which is what you usually do when you make real life projects. So you should expand your Java project file and go under source file and create a new class. I'm gonna call this class factory. Now, just because we've created this class, we can go in our application class and create a factory object. I will say factory1. This is how I'm gonna name it. I'm gonna say new factory. So we've just created a new object. And now I'm gonna go in our factory class and give this class few methods. I'm gonna say public void design. Here I'm gonna say sysout control space design the car, and then I'm gonna add another method. Here I'm gonna say public void build and sysout build the car. So in my application class I can call my methods. I can say factory1 dot design and factory1 dot build. Now our sysout statements will be displayed in the console. As you can see, design the car and build the car. So you need to have a good understanding of creating and calling methods before you move to inheritance. Now we're gonna create another class and we'll call it car. I'm gonna go to our source file, go to class and type here car. And I can make a reference to a new object of car class. I'm gonna say car1 equals to new car. And if we go to our car class, we don't have any methods yet. But if we do this, car1 dot, you can see that we actually can call some methods, and these methods are parts of the object class, and this class is the ultimate ancestor of all classes in Java. But if I go to our car class and I say here car extends factory, what I mean by extend is that car now is a subclass of factory and factory is a superclass of car. So now car class inherits everything from factory class. So at the moment car class is identical to our factory class. Just by mentioning here that car extends factory or car is a factory, in our car class now we have all the factory methods. So now we can go in our application class and say car1 dot design and car1 dot build. So now we have access to the methods in our factory class. So if we run this, design the car and build the car will be again displayed in the console. But we can go to our car class and add other methods, of course. So here I'm gonna say public void, let's say brand, and I'm gonna say sysout, let's say Tesla. And now I can go in my application class and say car1 dot brand. So now we have methods in our car class that we don't have in our factory class. And this is very useful because if you don't have the source code of a class, you can only extend it and add your own code as well. So basically you can extend any class except final classes. An example of final classes is a string class, so you cannot extend the string class. With an exception of final classes, you can extend basically any class. So now that you have an idea of inheritance, we're gonna go through access modifiers. There are 4 access modifiers. There is public, then there is protected, then there is default, and this one is a little bit tricky because it has a name, but it occurs when there is no access modifier. So let's say here lack of access modifier. And an example of this could be this method. If we delete public and just say void brand, this is the case when the method has a default modifier. I'm going to put it back to public. And lastly, there is private. So public access modifier means that you can access these methods from any class, anywhere, regardless of whether the classes are or aren't in the same package. Whilst the keyword protected, if we say for example here protected, it means that this method can be accessed from this class, from other classes in the same package, but if the class is in the different package from where you're trying to access this method, that class has to extend the class that this method is in it. So for example, we need to extend the car class because this method belongs to the car class. So in order to access a protected method, you need to extend the car class. So only the subclasses from different packages can access protected methods. Now moving on to default or lack of access modifier. So a method with default modifier would look like this. And you can call this method only from the same class or the classes that are in the same package. So if a class is not in the same package as the car class, you cannot access this method regardless of whether it is a subclass or not. So a method with a default access modifier can be called only within the same class or the classes within the same package. Whilst private access modifier is very simple and very straightforward, you can call a method with a private access modifier only within the same class. You cannot call a private method, even if that class is a subclass of the class that the method belongs in. So private modifier is pretty straightforward and very simple. The same as public one, which can be accessed from everywhere. So you should focus on learning these two a little bit more because they are more tricky, because public and private are pretty straightforward. So that's it for this lecture. We're going to use inheritance and access modifiers throughout the course, so I'm sure that you gradually understand them. For the moment, you can exercise with source code in the resources section. So I will see you in the next lecture.